Now there's an easier way we can create generators, providing the generator is simple. We're able to use what are known as generator expressions in order to do this. So similar to the lambda functions which create anonymous functions in a single line, generator expressions can create anonymous generator functions. And the syntax for generator expressions is similar to that of a list comprehension in Python, but the square brackets are simply replaced with round parentheses. Now the major difference between a list comprehension and a generator expression is that a list comprehension produces the entire list, while the generator expression produces one item at a time, as I'm sure you've guessed. Generator expressions also have what is known as lazy execution, and that essentially means it produces items only when they're asked for. And for this reason, a generator expression is much more memory efficient than an equivalent list comprehension, as a list comprehension would store the values in memory. But a generator expression will only yield a result when the caller has asked it to. So to demonstrate this, I'll first of all create a list called my_list, and we'll set this equal to a list of integers 1, 2, 3, 4, and 5. Now, if I wanted to create a list of values which doubled each element in this list, I could utilize list comprehension as follows. So we'll store the result in a variable called list_comp, and we'll set this equal to square brackets, and then we will put I, which will represent each element in this list, multiplied by 2 for I in my_list. Hopefully this syntax looks familiar, as we covered it earlier in the course. If I now take a look what's stored in list_comp, we get a list of integers 2, 4, 6, 8, and 10, which is our original list doubled. Now the same thing can be done using a generator expression. So if I create a variable called gen_exp for expression and set this equal to round parentheses and then inside put I multiplied by 2 for I in my_list, so exactly the same syntax as our list comprehension, with the only difference being the brackets that we're using either side, you can see that when I now take a look to see what's stored in gen_exp, we have a generator object at this location in memory. And what can we do with generator objects? Well, we can loop through them and call upon the next element accordingly. So if I print out the result of calling the built-in next function and then pass in our generator object, so gen_exp, you can see that we get 2 printed to the screen, which is that first element doubled. If I now copy and paste this 4 more times and then print the result of this code cell, you can see that we get 4, 6, 8, and 10 printed to the screen. Unsurprisingly, one more time will produce that stop iteration error. So we can see that the above generator expression didn't produce the required result immediately. Instead, it returned a generator object which only produced the items on demand. Now, another useful thing I want to show you with generators is that generator expressions can be used as function arguments. In other words, they can be passed into a function as an argument to a parameter for that function. And when generator expressions are used in this way, the round parentheses can be dropped. So let's take the simple built-in function known as sum, which will sum the elements of an iterable of numbers. So if we put sum and then parentheses, we can now put a generator expression. So if I put I multiplied by 2 for I in my_list, you can see that when I run this code cell, we return 30, which is the sum of 2, 4, 6, 8, and 10. If I copy and paste this code cell and change the sum function to max, you can see that when I run this, we get 10 returned because 10 is the highest number in this iterable. Now that we've seen generators in a few examples and observed generator expressions, in the next video I'm going to run through some of the main benefits of using generators, which will hopefully make things clearer as to when you should use them. So I'll see you in the next video. In this video, we're going to discuss a few benefits of using generators. And the first thing I want to do is cast your mind back to when we created that times 10 class, which essentially allowed us to build out an iterator by including the iter method and the next method accordingly. We handled the states of n and we compared it to max. We multiplied n by 10. We then incremented n by 1 and then returned the result. And we raised the stop iteration when there were no further elements to be iterated over. Now, to create this class, it's quite long and can also look quite confusing to those who are unfamiliar with this type of implementation. But the good news is we can create the same thing using a generator function, using much less code. So to recreate this, I could create a function called times 10, and then I can pass in a parameter called max, which will default to 0. We can then create a variable called n, which will set to 1, and then we can simply put while n is less than or equal to max, then yield n times 10. We then need n to be incremented by 1. And that's all we need to do. We know that generators keep track of all the details automatically, so this implementation is much more concise and so much easier to read. So let's create a variable called a, and we'll set this equal to times 10, and in brackets we'll pass in the max to be 3. We can now loop over our iterator object, which is a, so we can put for I in a, simply print I. When I do this, we print 10, 20, 30 to the screen, and we've been able to produce the same iterable using generator functions, which I'm sure you'll agree is much easier to read. So the number one benefit, generator functions are easy to implement. Now the second benefit of using generators is that they are memory efficient. If we were to return a sequence using a normal function, it will create the entire sequence in memory before returning the result. Now if the number of items in this sequence is very large, it could cause issues if your computer doesn't have enough memory to store this information. But implementing the same thing using a generator function will enable you to create the same sequence in a much more memory-friendly way. And this is because it only produces one item at a time, and doesn't need to create the entire sequence in memory before returning the result. So the second benefit of using generators is that they are memory efficient. And the third benefit I want to share is the fact that they can actually represent an infinite stream in a finite amount of memory. So what do I mean by this? Well, infinite streams can't be stored in memory, unless you have an infinite amount of memory on machine, which we know is not possible. And since generators produce only one item at a time, they can actually be used to represent an infinite stream of data theoretically. So if I wanted to create a generator function that generates every single even number, I could create a function called even_numbers with parentheses and a colon. We'll first of all set n to equal 0, and then we can put while true, colon, yield n, then increment n by 2. So this generator function can actually generate all of the even numbers, since it will only access one item at a time when you iterate through the object. If you were to try to store all even numbers in a list, well, you'd need to create the entire sequence in memory first, but seeing as there is an endless amount of even numbers, it would never get to the point where it's returned. So the third benefit of using generators is that they can actually represent infinite streams. So hopefully the last few videos have shown you how generators can be used and how they're beneficial. They are certainly a very powerful feature in Python and will help you tackle your iteration problems that you may face in your coding journey. Before moving on to the next section, let's check your understanding of generators with a quick quiz.